Thanks for watching this screencast. The objective of this screencast is learners will be able to determine the inverse of a discrete relation. So the definition of an inverse is right here. Given a relation, the inverse of the relation is the relation that undoes the original relation. In other words, it's the relation that takes the range of your given relation as the input, as the domain, and spits out as the range the original domain. So here's a very basic example. Given this relation as a mapping, this is a discrete relation because it involves a finite number of ordered pairs. So we've got the ordered pair 1, 2, 4, 5, 4, -5, and 2, 0. The inverse of that relation would be another relation that takes as the domain the previous relation's range. So 2, 5, -5, 0, and creates as the output the range the original relation's domain, 1, 4, 2. So what's left to do here is to make sure that we've hooked up the proper elements from the domain to the proper elements of the range. So I see that the ordered pair 1, 2 was in the relation. I need to make sure that my inverse contains 2, 1. In other words, it undoes that. This relation maps 1 in the domain to 2 in the range, so the inverse needs to map 2 in the domain to 1 in the range. I see the ordered pair 4, 5, so I need 5, 4. I see the ordered pair 4, -5, so I need the ordered pair -5, 4. And since 2, 0 is in the relation, 0, 2 needs to be in the inverse. Here are two more examples. Given each relation, find its inverse. So here I have a set of ordered pairs. The inverse will be the same set of ordered pairs reversed. If 4, -3 is in the relation, I'll write it beneath, then my inverse should be the same ordered pairs undoing each other. 4, -3, I need -3, 4. Here's the ordered pair 3, -1. Well, I need -1, 3. If 2, 9 is in the relation, 9, 2 should be in the inverse. And if -5, -1 is in the relation, I need -1, -5. Here's a relation given in part B as a table. It seems kind of nice to do to give the inverse also in a table. It doesn't mean you have to. You could list it like a set of ordered pairs, like in A. But I see 1, 6, so I need 6, 1. -3, 2 means the inverse needs 2, -3. 5, 0 means I need an ordered pair at 0, 5. -1, -5 means we need -5, -1. And 4, 2, we need 2, 4. And this relation here is the inverse of that relation, the given relation. You know what time it is. Hit pause. See if you can find the inverse of each relation. And when you think you've got it, hit play. If we look at A, this relation, this set of 5 ordered pairs, I need the inverse of each ordered pair. I need to undo each ordered pair. So if this relation inputs -2 and spits out an 8, I need an ordered pair that takes in an 8 and spits out -2. If 2, 8 is in the relation, then the inverse contains 8, 2. I also need -1, -3. I need 0, 5. And I need -2, 6. On part B, I've got a mapping. I think I'm going to write the inverse as a mapping. So domain and range. I see negative 9, 1. So I'll do 1, comma, negative 9. I see negative 5, 5. So I need 5, negative 5. I see 1, comma, 8. So I need from 1, I need from 8 to 1. I almost messed that up. The inverse has to undo that. So if 1, 8 is in the relation, 8, 1 should be in the inverse. I see 7, 1. So I need an ordered pair that goes from 1 to 7. And I see 7, comma, 4. So I need 4, comma, 7. And there we have it. How'd you do? Thanks for watching.